Hello everyone, welcome to the live class. So guys, today we are having a practice session 4, okay? And before this we have already conducted the practice session 1, 2 and 3. Clear? So if you have not watched those sessions, you can watch the recordings because the recordings will be available to you on this channel, that is Unacademy Live CSIR UGC Net. Now, in this today's session, we will again talk about some of the very important questions, okay, which will surely help you to prepare very well for your exam and to know about the very important concepts, tricks and important steps. Clear? Now, before starting the discussion about the questions and the important concepts, guys, I'm going to take a little time to let you know about the Unacademy Plus subscription. Clear? And there is one more information I want to share with you, that is about the Unacademy Plus subscription amount. So the Unacademy Plus subscription amount for the 1 month has been increased, clear, and for the 2 years, okay, it has been reduced. So you can just check it once in the Unacademy Learning app as well to get to know about the exact changes, clear. And if you are preparing for the CSIR NET Physics exam preparation, you can take the Unacademy Plus subscription to attend the more regular live classes for your upcoming exam preparation. Clear? And also guys, once when you will take the Unacademy Plus subscription, you will be able to attend the live classes of well structured courses by all the top educators. Also weekly quizzes will be there, doubt clearing sessions will be there. So if you want to get all these benefits, you can take the Unacademy Plus subscription. Also there is one more benefit you can get, that is by using the referral code AnjaliALive, okay, and by applying it you will get the 10% discount in the total Unacademy Plus subscription amount. So these are the benefits you will get after taking the Unacademy Plus subscription. If I'm going to talk about the referral code, if you even know the Anjali Arora referral code, you can apply it and you can even get the 10% discount with that. So use any one of the referral codes out of these two, either AnjaliALive or Anjali Arora. Just use any one. Clear? Next thing, there are many courses going on Unacademy Plus for your exam preparation. So if you want to take the Plus subscription, you can take the Unacademy Plus subscription, and that's how you will be able to prepare very well for your exam, and that's how you will be able to get many benefits. Clear? And guys, for your upcoming exam, if you are going to take the subscription, you can take the subscription for either 3 months or 6 months because they are going to be very much beneficial for you. Clear? And all these courses will surely help you to take your preparation to the next level and to prepare very well. If I'm going to talk about the steps to take the subscription, guys, so step number 1 is download the Unacademy Learning app. Step number 2 is log into the app. Then select your goal. Your goal will be CSIR UGC Net if you are preparing for CSIR Net Physics exam or any category CSIR Net exam. After that, guys, you will have the 3 lines present at the left hand side corner. Just click on those 3 lines, then click on plus, and then follow the further steps after clicking on get subscription. And at the place of writing the referral code, either write AnjaliALive or Anjali Arora, okay, and apply the referral code and get the 10% discount in the total Unacademy Plus subscription amount. All these are the benefits you will get, guys, after taking the Unacademy Plus subscription. Now, even after the session, if you will have any doubt, any query or anything you want to ask regarding the Plus subscription, you can even send me the message in the Unacademy Learning app just by searching my name Anjali Arora. Okay, you will get the that message option there or the symbol of the message there. So just by clicking on that symbol, you can send me the message and ask about your doubts or queries. Clear? Now let's continue the discussion and let me just tell you about some of the very important questions which we are going to discuss in our today's session. Okay, and also guys, if you are having any doubt from the discussion which we have done in the previous classes, in the previous sessions which were practice sessions, you can let me know about your doubts as well. So very good morning Arun, hello Krishnendu, and hello Kirti. So guys, one by one we are going to take the questions of different subjects, but very important questions. Guys, let's just start with the classical mechanics part. Clear? And let me just tell you about the first question we are going to do. That's from a very important concept. I hope you all know about the central force. Okay. And related to that, we are going to do the first question. Guys, please try it once and let me know when you will get the answer. Hello, Sunil. And if you will not get the answer or you are not familiar with this concept, clear, I will let you know. Hello, Jaswinder. Guys, if you will have any difficulty in solving this question, then also you can let me know. If you will get the answer, then also you will let me know. If you don't know about the concept, we will do the discussion. Very good, Kirti. Waiting for more answer, guys. So once you will get it, please let me know. Just one answer till now. Guys, let me know. Can I start the discussion? Because this question doesn't require this much time. Okay, so let's start the discussion now, and if you will have any doubt at any point, you will let me know about it. Now guys, the question is, two particles of identical mass move in circular orbits under a central potential. So from this statement we have got the idea that okay, somewhere this question is related to central force. Clear? So central potential is given to you, where L1 and L2 are the angular momenta, and R1 and R2 are the radii of the orbits respectively. If L1 upon L2 is equal to 2, the value of R1 upon R2 is. This is what we need to find. Clear? Now guys, in this case, what will happen? You need to know one concept. What is that? Anytime if your question is related to the angular momentum, clear, and related to the circular orbit or central potential, but main hints or main points in the question are these ones: circular orbits and the angular momentum term is present here. So whenever we talk about the potential, we can't use the direct potential expression given to us in this case. We use the potential expression, which is going to be the effective potential expression. Okay, because the angular momentum is involved in this question and also related to circular orbit. So effective potential expression is going to be L square, that is angular momentum square, upon 2mr square plus Vr. Clear? Vr is the potential given to you. L is the angular momentum. R is the distance or the radius which has been given to you. Clear? Now, in this case, you are having two different situations given to you. Now, next thing is what they are asking us to find. They are basically asking us to find the ratio of R1 and R2 when they have given us the ratio of L1 and L2. So first thing is this, which should be clear to us. Clear? In general, if with this effective potential, what I have to make, like the changes I have to make, these changes will be that in place of L I have to write L1, L2, in place of R I have to write R1 and R2. But the potential which has been given to us, that is central potential, is same for both. So that means potential expression will remain same, but in place of L and R I have to make the corresponding changes for first and the second. Clear? So let me just write this potential term here, that is half kr square. Okay, now next thing. Guys, the rest of the procedure will remain same, but now instead of considering the potential, you have to consider the effective potential. Like in the small oscillations case, what we do? We want to find the equilibrium points, and to find the equilibrium points, we equate the first order derivative of the potential with 0. And here we will focus on effective potential. So we equate the first order derivative of the effective potential with respect to R. When we will find it, we'll equate it with 0, and that's how we are going to get minus L square upon mr cube plus kr is equal to 0. Clear? In general, we are finding it out right now. After this, what will happen? After simplification, you will get from here, that is going to be L square. Okay, let's do the complete simplification for this. So it will become m k r to the power 4, where k is a constant, m is a constant. So can I say L square is proportional to r to the power 4, and then can I say L is proportional to r square? Done. Now we are having L1, so L1 will be proportional to r1 square, and L2 will be proportional to r2 square. So we can write these two equations, and let's take the ratio, because we are having the values of L1 and L2 given to us. Okay, rest of the constant terms will like normally get cancelled out. So here we will get L1 upon L2 is equal to 2, which will be equal to, because after taking the ratio, it will be normally we can write in this way, because they were constant terms which will simply get cancelled out even if I will not take the proportionality sign and will take all the terms. Clear? After this, what will happen, guys? Implies R1 upon R2 is equal to root 2. Okay, so this is going to be the ratio of the radii, that is going to be R1 and R2. Clear? So here we are getting root 2 as the final answer, which is option A, which is our right answer. I will summarize all the steps once. That's going to be step number 1. How we are getting the idea from the question that we need to use the formula of effective potential instead of using the direct potential expression given to us. So when we are reading this question, we are getting that the question is related to circular orbits and are related to, this question is related to L1 and L2, that is angular momentum. So whenever your question will be related to circular orbits or angular momentum terms will be given to you there, then in this case, okay, then in this case what will happen, you will use the effective potential formula, which is L square upon 2mr square plus VR. Clear? In this case, what is going to happen, since in the question you are having different angular momentum terms given to you, L1 and L2, and they are just asking about the ratios corresponding to R1 and R2. So initially you have found out the dependency of L on R, and later on you have just found their ratios, and that's how you are reaching to the final answer. Still, if there is any doubt anybody is having, let me know. No, Kirti, like in this kind of situation for circular orbit only, and when it is related to angular momentum, we are writing the effective potential, which is this one. Clear? Bhagyashali, there are particular dates when we are going to have the sessions on this YouTube channel, that is Unacademy Live CSIR UGC Net. Clear? So after this today's session, we will have next live class on 20th February. Clear? So next live class at 11 a.m. on 20th we will have here. Clear? And then on 21st, then on 22nd, but from 20th next class we will have. Kirti, please have a look at these steps and let me know if there is any doubt. This is just to find the equilibrium points. This is just to find the equilibrium points. As we do in the normal kind of stability analysis based questions, that same concept we have used here. नहीं, देखिए, जब ना आपके पास पोटेंशियल होता है, ठीक है, अब आपको मान लीजिए पता करना है कि कौन सा पॉइंट स्टेबल है और कौन सा वाला अनस्टेबल इक्विलिब्रियम पॉइंट है. तो उसके लिए सबसे पहला स्टेप होता है कि हम फाइंड करते हैं इक्विलिब्रियम पॉइंट्स. ठीक है, और जब हम इक्विलिब्रियम पॉइंट्स की बात करते हैं तो भले ही वो सर्कुलर ऑर्बिट के लिए लें या हम नॉर्मल स्मॉल ऑसिलेशंस के केस में नॉर्मल पार्टिकल के लिए लें, तो हम उन इक्विलिब्रियम पॉइंट्स को फाइंड करने के लिए फर्स्ट ऑर्डर डेरिवेटिव को जीरो से इक्वेट करते हैं, एंड आफ्टर इक्वेटिंग इट विद जीरो we get this kind of like equilibrium points. That's going to be the value of r in this case. Is this clear, Kirti? तो इक्विलिब्रियम पॉइंट्स आपको जब भी फाइंड करना होगा आप यही स्टेप्स लेंगे. हेलो सुभाष, आई एम गुड, हाउ आर यू? Clear? Guys, if there is any other doubt anybody is having related to this question, you can tell me about that and we will do the discussion about that point. Our next question is, Guys, please try this question and let me know once you will get the answer. And if you will have any doubt or difficulty in getting this answer, okay, let me know. We'll talk about like the important steps or important tricks for this kind of question, because there are going to be few hints. Like in the previous question we have talked about it. Okay, that what is going to be the hint for us that when we need to use just the normal potential or the effective potential. Similarly, we will talk about it here. Clear? Very good, Kirti, but if possible, check the calculation once. If possible, just check it once, clear whether it's B or some other option, which will be correct according to you. So guys, you can ask the questions which are related to the session or the topics, clear, or your exam preparation. So that's like you can ask about these things or the questions related to your syllabus. And guys, once you will get the answer, please let me know which option is correct according to you. And if there is any difficulty in getting the answer or the steps, let me know. We will do the discussion about those points. Yes, Kirti. Option A is here on this slide. Then B and option B, option C and option D are here. That's very good, Kirti. Now your answer is right. Clear? Now guys, is there anyone who has got the answer or trying? Is there anyone who has got the answer? Huh. So guys, like Kirti, the mistake you have made earlier, clear, due to which you are getting option B as the correct option, please focus on that so that next time whenever you will do this kind of question, you will not make this mistake again. Clear? Now let's talk about it, guys. So, very good, Kirti, because you have got the answer. And guys, if there is someone else who is getting the answer, you can mention it in the message once. Okay? And we are also starting the discussion about this question. So the question is, a particle of mass m moves inside a bowl, clear, if the surface of the bowl is given by the equation that is z is equal to half a into x square plus y square. So this is our question where a is the constant, clear, the Lagrangian of the particle is, so we need to find the Lagrangian. Now guys, for this kind of question you need to know one thing. What is that? There are few hints which have been given. Like anytime if we are going to talk about any system which is in the shape of a bowl, then in this case what is going to happen? In this case we prefer the coordinate system to be used, that is going to be the cylindrical coordinate system. Clear? For this kind of system we prefer the cylindrical coordinate systems. Clear? So whenever you will write the terms, the values, you will prefer this coordinate system there instead of preferring the Cartesian or the spherical polar or the polar. Clear? This is what you will prefer. If the surface of the bowl is given by the equation this, so that means we just want to convert the things in terms of cylindrical polar coordinate or cylindrical coordinate system. So first of all we want to get the Lagrangian, and Lagrangian is generally L is equal to T minus V, where T is what? T is the kinetic energy, V is what? V is the potential energy, and you know T in terms of Cartesian coordinate system we write half m x dot square plus y dot square plus z dot square. Clear? And potential we write potential energy as mgh, but in case of h, like in this case, in place of h you can write z, so which will be mgz. Clear? Now guys, if I'm going to talk about the final expression, so since I have told you in this kind of question we prefer the cylindrical coordinate systems, that means we have to put the values of x, y, z in terms of cylindrical coordinate system. And what is the relation between the Cartesian and the cylindrical coordinate systems? So let me just tell you about that. That relation is x is equal to r cos theta or r cos phi, whatever you want to consider. But if you will observe the options, mainly if we are going to talk about two coordinates. See, for the cylindrical coordinate system we are having the coordinates r or s, theta, z, or you can say s, phi, z for cylindrical coordinate system. Clear? So right now that's why we are preferring to have two coordinates. So whenever they have been given two coordinates, you can see r and phi are present there, not r and theta. But here if you will observe this option, it's r, theta and phi, which means a spherical polar. But we don't want the answer to be in spherical polar, so we will prefer the cylindrical. And when we are going to prefer the cylindrical, three coordinates will be r, phi and z. Clear? So you can say either in this option just r and phi are present. So that's why I'm writing x is equal to r cos phi instead of r cos theta, y is equal to r sin phi. Clear? And z is already given to us, that is half x square plus y square, and a is also there. And do you know, if you will write x square plus y square with this x and this y, it will give you sin square phi plus cos square phi, which means 1. So you will simply get half a r square for z. Clear? So you can do one thing. In this expression, you can simply, in the last expression, you can simply put the values of x dot, y dot and z dot. So with these expressions, what you will get the value for the x dot? See, when we are saying x dot, what it means? With respect to what we need to do the differentiation? We need to do the differentiation with respect to time t. So it will become dx by dt. Clear? So when you will do the differentiation of x with respect to time, it will give you because you have to use the product rule here. Clear? So these are going to be x dot, y dot and z dot values. Just put these values in the expression, which is this one. Clear? Just a second. Yeah, this one. Clear? So half m x dot square plus y dot square plus z dot square minus mgz. So when you will put those values here, you will get your expression will directly match with option D, and that's going to be your right answer. Clear? So guys, you can simply have a look at the expression or the steps we have taken till now. Still, if you are having any doubt in any of the steps, you can let me know about it. Clear? So, is there any doubt anybody is having? And guys, I hope that with these discussion about the different types of questions, you are getting the clear ideas about the steps you need to take for different types of questions in different steps. Clear? And let's talk about the next one if there is no doubt in this question. But if you will have any doubt, you can let me know. Please try it once and let me know which option is going to be the correct option according to you. That's very good, Kirti. Hello, Debajani. Very good, Sunil. What about others, guys? Which is going to be the correct option for this question? Very good, Arun. Very good, Hari. Okay, so I've got like two different answers from your side. One is option A, another one is option B. Clear? But option A is correct, not B. What is the reason behind that? Even option B can be the possible one, or anybody can relate it with option B. But why it's not correct? What is the reason behind that? Let's talk about it first. See, guys, here the Lagrangian is given to us in the question, which is x dot square upon 2x minus Vx. Clear? And in general, we know that Lagrangian is nothing but T minus V. That means the kinetic energy minus potential energy. Clear? And we also know Hamiltonian is kinetic energy plus potential energy. Clear? Now in this case, what we will do? Along with this information that what is Lagrangian and what is Hamiltonian, we also need to know about one more thing, that is Lagrangian is always going to be a function of generalized coordinate and generalized velocity, while Hamiltonian will be considered as a function of generalized coordinate and generalized momentum. If you want, you can directly write it, that is x dot square upon 2x plus vx. But if you will look at the options given to you, all the options are not just in terms of x dot and x, they are also in terms of momentum. So you have to check, okay, that whether you are getting that option in which the momentum is present, or you are getting that option in which the velocity term and the coordinate term is present. Clear? So if there will be no such kind of option, then you may get that, but this kind of questions you will not get in the exam. Clear? So every time when they are asking about the Hamiltonian, they will give you the function of momentum and coordinate. Okay, now guys, how we can simply find it as a function of coordinate and momentum? Do you know the trick for that? Are you having some idea about that trick which will help you to get the answer just simply in few seconds? When you want to do the conversion from Lagrangian to Hamiltonian and you want to get the expression in terms of momentum, generalized coordinate and generalized momentum, so what is the trick? So guys, there is a trick, that is, if Lagrangian you know, clear, and you are able to identify the kinetic energy and potential energy separately. So in this expression which is given to you, that is x dot square upon 2x minus vx, x dot square upon 2x minus Vx. So in this case, are you able to understand or get this thing, that what is the kinetic energy term? I think yes, it's simple and easy in this expression, that is, this is kinetic energy. Done. And in this case guys, what is our trick? Our trick is that relate the kinetic energy term present in the Lagrangian with half mv square and get the value of m from there. Clear? So what is m which you will get from here? If I'm going to write it in this way, that is half m. In place of m we will just get 1 upon x. Clear? And v square, in place of v square you will get x dot square. So what you are getting in place of this m? You are getting 1 upon x. Clear? So m is equal to 1 upon x. Done. After getting this value of m, okay, you need to write the Hamiltonian in such a way that you will just use the formula p square upon 2m for writing the kinetic energy. Clear? Because Hamiltonian is a function of generalized coordinate and generalized momentum. So it's going to be 1 upon x. The value of m is 1 upon x. Clear? Next thing is, if we are going to talk about the rest of the expression, it's going to be p square upon 2 into 1 upon x plus v. Clear? What I have done, in place of kinetic energy I have used p square upon 2m plus v. Okay, next thing, what is m? M is equal to 1 upon x. So it's going to be p square upon 2 into 1 upon x plus v. When you will simplify it, you will simply get p square, just let me write it here, x upon 2 plus v, which is our final answer. Clear? And let's have a look at the options given to us and let's check which option is correct. So p square x upon 2 plus v, which is option A. Is this clear to everyone? Clear? That's good. Also guys, the trick is going to help you a lot to write the Hamiltonian expression from the Lagrangian, or even from the Hamiltonian if the Hamiltonian is given. Clear? And you will write the Lagrangian, since like in this case also you can do it in the same way. Clear? Just do the comparison of kinetic energy terms and then write the other expression corresponding to the kinetic energy values which we consider. So if you are writing Lagrangian, you will consider kinetic energy half mv square. If you are writing Hamiltonian, consider it p square upon 2m. Clear? Guys, if you are having any question or any doubt or any query for this question or in its steps, okay, let me know. And if everything is clear, that's very good. Clear? Okay, that's good. We are having the question which is going to be our next question, which is also, guys, the concepts which I have explained you in this session, clear, it will be related to one of those concepts. So everybody will try this question, and once you will reach to the answer, you will let me know. If still you will have any doubt or difficulty, you can let me know about that, and we will do the discussion about those points. Guys, this is the question. And I'm going to write the options corresponding to this question once. Okay, so till then you can start solving it. The question is, a planet of mass m and an angular momentum L moves in a circular orbit in a potential Vr is equal to minus k by r, where k is a constant. If it is slightly perturbed radially, the angular frequency of radial oscillation is. Okay, so here we are going to have the options for this question. Okay. So guys, these are the options. Please try it once and let me know which option is correct according to you. Also guys, once you will get the answer, okay, with whatever option you are getting as the correct answer, you can let me know. Yes, Hari, here are the options. Guys, I hope after reading this question you are easily getting the concept involved and the steps you have to take to solve it. Clear? There are a few points which we have already covered in our I think first or second question, which was related to central force or central potential, and circular orbit was included. Clear? None? Square root 2 cube. Are you getting square root 2 cube? Guys, I think you will get option B as the correct option. Okay, let's do it together. Let's try to solve it once. Clear? And let's see whether we are getting it or not. First of all, very good, Kirti. Yeah, that's correct. Clear? So option B is correct and you are getting option B. That's correct. Now guys, if we are going to talk about this question, the question is a planet of mass m and angular momentum. So again, you can see here the angular momentum is involved in this question. Clear? As I have already told you about this trick, that whenever the angular momentum is included or is involved or has been considered in the question, then you have to go for the effective potential instead of going for the normal potential expression. Clear? Similarly, the circular orbit is also present here. So what we will do, instead of using this potential expression which has been given to us, we will go for the effective potential. And excuse me, and how we can write it, that is V effective is equal to L square upon 2mr square plus, or it's going to be V. Clear? But in this case we are having, this is what this is, yeah, C plus V. Clear? So here V is equal to what? That is minus K by R. Put V is equal to minus K by R here. Clear? This is the effective potential you are getting. After this, you have to take the normal steps which you take in normal small oscillations based questions. And what are these steps? The steps are, like, initially we need to find the effective potential. We have found it out in this case because question was related to angular momentum and was related to circular orbit. Clear? So that's what we have done. We have already found it out. So now we know the potential we need to use. Second step will be to find the equilibrium points. So if we want to find the equilibrium points, for that we have to equate the first order derivative of this potential with 0. Clear? And whatever values of r we will get from here, those values will be known as the equilibrium points. At those equilibrium points, you may have the stable equilibrium point present or unstable. So if you want to check, you can find the second order derivative and you can check it. And later on, if you want to find, like, once you will find the values of r, they are going to be, from here just one value we are getting, that is L square upon mk. So after doing this simplification, you will get the value of r, which is L square upon mk. After this step, guys, we all know omega is square root k by m, where k is going to be d2v by dx square, that is the, or dr square in this case, that is the second order derivative of the effective potential at r is equal to r naught. If I am saying this is point which is r naught, which is the equilibrium point. Clear? So here I will find the value of k, and later on the k value which you are going to get, that will be equal to, let me just tell you the value so that later on when you will just do the simplification or you will try to find it out, you will have a clear idea what value you should get. Okay, this is what you will get for k. Just put that value here. Okay, and after finally solving it, you will get mk square upon L cube. So by putting it back in this expression. Clear? So that's how you can finally get the answer, guys, which will match with option B. I hope that each and everything now will be clear to everyone. Clear? And if you are having any doubt, let me know. Yeah, very good, Hari. Very good, Sunil. And very good, Kirti. So guys, these are the basic things which can make a big difference, a large difference, clear, in the answer, or can even make your answers wrong if you will not focus on these little things. So they are very, very, very important. Okay, and you will easily be able to know about the exact steps and the right steps you need to take. Yes, Arun. Anytime if your question is related to angular momentum or circular orbit, then you can't use the normal potential given to you. In this kind of question, you have to go for the effective potential, for which the formula is L square upon 2m, here I have written it. L square upon 2mr square plus V, where V is the potential given to you, but this is the effective potential you will use in this kind of questions, and rest of the steps will be similar to the stability analysis case which we do. Clear? Like initially we will find the equilibrium points, then we will find the stable or unstable equilibrium points, or then we'll find the angular frequency, that's omega is equal to root k by m, where k is the second order derivative of the potential. But instead of considering just normal potential, you have to consider the effective potential in this kind of question when they are related to angular momentum or circular orbit. Clear? So is this okay? Is this clear to everyone? Clear? Done? Okay, that's good, guys. Clear? I hope that each and everything which we have discussed in this session will be clear to you. But still, if you are having any doubt in any of the questions or the important points I have discussed with you, clear, you can let me know about them. And if everything is clear, that's very good, guys. Our next session will be on 20th February at 11 a.m. Clear? So if you are having any doubts, any queries, or anything you want to ask, you can let me know related to the discussion we have done. Okay, so if you are having any doubt in any of the questions, you can mention. Okay. So guys, thank you very much for joining this session. And there's one more thing, like even if you want to take the Unacademy Plus subscription for your upcoming exam preparation, you can take the subscription. And wherever you will take the subscription, you can use the referral code, that is AnjaliALive or Anjali Arora. Any one of the referral codes you can use. Clear? And apply them and get the 10% discount in the total subscription amount. But you will use just any one of the referral codes. Okay. Also guys, there are so many courses going on Unacademy Plus for your upcoming exam preparation. So if you want to take the subscription, you can take the subscription and attend the important courses going on Unacademy Plus for your exam preparation. And guys, there we are having the subscription for different duration, like 1 month, 3 months, 6 months, 12 months and 24 months. Clear? So whatever you find convenient and good for you, you can go for that. But 3 months and the 6 month subscription will be good for our upcoming exam. Clear? Next thing, what are the steps to take the subscription, guys? So steps are, initially you can download the Unacademy learning app, then log into the app. After login to the app, select the goal. Your goal will be CSIR UGC NET if you are preparing for CSIR NET physics exam or any category CSIR NET exam. After that, guys, you just need to click on the 3 lines present at the left hand side corner, and after that just click on plus and click on get subscription after that. Clear? And follow the further steps. So that's how you can easily take the subscription. Also guys, these are the benefits you will get after taking the Unacademy Plus subscription, like well structured and the well planned courses will be there, which will surely help you to take your preparation to the next level. Clear? Weekly quizzes will be there, doubt clearing sessions will be there, mock tests, PDFs of important notes will also be available to you. Also guys, recordings of the live classes will be available to you. So any day if you will not be able to attend the live session, you can watch the recordings, and that's how you will be able to cover up many things. Clear? And you will not miss anything. Next, if we are going to talk about other benefit, that is that after taking the subscription, you will be able to attend the live classes by all the top educators. So that's going to be one of the best thing. You will get the guidance by all the top educators. Clear? For your exam preparation. And guys, thank you very much for joining this session. I hope that the sessions are going to help you to know about the important concepts, tricks and important questions and the steps to solve the questions for your upcoming CSIR NET physics exam. Thank you very much everyone for joining this session.